applications. Another calcareous metamorphic stone, and wrapping up the calcareous section of the chemistry, is serpentine. This is a rock group mainly principally of the mineral serpentine. They can have a greasy, silky feel to it, or a talky feel to it, some people would add. And the thing is with serpentines, they are always in that greenish to greenish blue color. That's one of the characteristics of the serpentine. It can also run a little bit green-gray. There's a wide range of quality of serpentine, so you've got to be careful when you're using it. The density level, whether or not it has calcium carbonate, a lot of that content that will react with acids, that's another issue, so you have to be careful of where that serpentine has come from. Here's a picture of serpentine in an exterior application. Again, the dark green. Before I move on to the siliceous stones, the basic thing that you need to get out of calcareous stones, and all those stones that we just talked about, which are marbles, limestones, travertines, and serpentine, the calcium carbonate content of it is what people are afraid of. Okay, the stone itself, many of them are very hard, many of them have low absorption rates, which make it perfectly suitable for a kitchen application or a bathroom application. The one element that we cannot protect from is the etching, which anything acidic reacts with calcium carbonate. So that's where you have an issue with the marbles in that whole family. So moving on to siliceous stones, talking about a sedimentary formed siliceous stone, is sandstone. It's very classic sedimentary rock, little grains, particles falling to the side. When you talk about sandstone, the name has a very relevancy to it because the grain of it is literally sand size. It can have iron oxide in it, it can have quartz or other silicas mixed in with it, but it commonly is done with quartz, is mixed with quartz. Generally, it's a more porous stone. You got to remember it's those small little particles of sand, so it's one of the more porous of all the dimensional stones that are out there. However, it still will be used in exterior applications because it can be sealed. Another siliceous metamorphic stone is slate. This is a compact microcrystalline metamorphic rock, as opposed to, we talked about the onyx that was cryptocrystalline, which you couldn't see the crystals at all, even under a microscope. Well, with slate, they're microcrystallines, so you can see the size of the grains in the crystals under a microscope, and they're usually formed in shale deposits in layers, and we'll see some of that when we talk about quarrying. They're exceptionally anisotropic properties. Unlike the isotropic properties of a travertine where they're directionally specific, slate is anisotropic. It really doesn't have a direction. It is quarried in a specific direction, but once you get those pieces out, it really has an anisotropic property. One of the things about slate is it's the only natural stone that it has a slaty cleavage which allows it to be split into very thin sheets, and many of you may know that often used as roofing material, they will use slate shingles. Here's an example of a slate floor. It comes in many different colors. Another siliceous metamorphic stone is quartzite. This is a metamorphic rock consisting mainly of quartz, hence the name quartzite, formed by the recrystallization of sandstone. So this was once a sandstone that metamorphosed into a quartzite. It joined with a lot of different quartz, and through a regional and thermal metamorphism, so some type of movement in the earth of where it was formed, as well as intense heat from the center of the earth. And this is why this recrystallized into a quartzite. Quartzite's a very durable material. They're growing more and more in its popularity simply because they can have a look of a marble, but they have more qualities and properties that are attributed to a granite, which are very durable. So this has become a more popular mode of choice. Here's an example of the siliceous metamorphic quartzite, which is, you can see it comes in many different colors. And the last is the siliceous igneous, which is granite. So again, we're talking about that plutonic rock, that unerupted molten lava that formed over millions and millions of years. Basically 10 to 50% of the felsic components in alkali feldspar, the total feldspar ratio is between 65 and 90%. This gives it a very tough durability where it has that much felsic component and quartz making it up. Commercially, it's any quartz-bearing plutonic rock is considered a granite. So there are many granites One that geologists will argue with us all the time, a very popular granite called absolute black, which everybody in the industry knows about. Technically, geologically, it isn't a granite, because if the quartz makeup, which is quartz is typically a white or a clear color, has to be 10 to 50% of the makeup, you would actually see the white in it. So a solid black, like an absolute black granite, technically is not a granite. And I talked about that a little bit before when we talked about the different species in the matrix of the stone, that they would fall in between some of the lines. So the absolute black is one that it categorized in that type of situation. High abrasion resistance, some of the characteristics, very good chemical and weathering resistancy, and it can be nearly isotropic to mildly anisotropic, again, directionally specific or not, depending on how the block is cut. Some of the granites will have a directionally specific look to it, and they will cut them in different directions. Granite, as you can see, here's an application used. There's a bottle of red wine in there. If you can't see it, there's some lemon cut up, and very good with acids. Again, going back to that basic chemistry, is not calcium carbonate based, but silicious based, or silica and silicate based. So it makes it a very durable choice. Well, I hope that this lesson was useful for you, and look to see some more videos from me. Again, I'm Jonathan Varengi, and I'm from Marble and Granite. Thank you.